Hi. So we will do today, October 2022, WST02 Part 01, International IAL Level Statistics 2 question paper. So we'll move to the question number 1. Straight away, we'll move to question number 1. So in this question, Bhavana produces rolls of cloth. She knows that faults occur randomly in her cloth at a mean rate of 1.5 every 15 meters. Find the probability that in 15 meters of her cloth, there are less than 3 faults, at least 6 faults. So here, this is a question that related with the Poisson's distribution. How you know that it is a Poisson distribution? See the keyword. It's mean rate of 1.5 every 15 meters. Mean rate of 1.5 every 15 meters. Correct? So first question, find the probability that in 15 meters of her cloth, there are less than 3 faults. So we will define first f. F will be the random variable. What is the random variable f? Number of faults in 15 meters cloth. Okay, so number of faults in 15 meters cloth. And how this f is distributed? F is distributed with the Poisson distribution with the mean rate of 1.5. So the probability of f less than 3. That is our question. Probability of f less than 3. So probability of f less than 3 means it is probability of f less than or equal to 2. Then you go to the cumulative Poisson distribution table, and then for lambda 1.5, for the x value 2, you see the probability, and that probability we will get it as 0.8088. So that is the answer for first part. Now at least 6 faults. At least 6 faults means probability of at least, that is the keyword, f greater than or equal to 6. Probability of f greater than or equal to 6. Greater than or equal to 6. So then there is no direct table to find this value. So instead, what we should do, we will do something like this: 1 minus probability of f less than or equal to 5. Then lambda value 1.5 and x value 5. You just go to the table, same cumulative probable Poisson distribution table, and then you input that value here. So that is 1 minus 0.9955. 1 minus 0.9955. So if you're substituting this value, you will get it as 0.0045. So that is the answer for this question. Clear? So what is the answer for this one? 0.8088. That is our answer. You can cross check it. This answer is 0.0045. 0.0045. Clear? So that is the idea about first part. It's 3 marks. Now move to the next part of this question. Each roll contains 100 meters of Bhavana's cloth. She selects 15 rolls at random. Find the probability that exactly 10 of these rolls have fewer than 13 faults. So now they clubbed the concept of Poisson distribution as well as this binomial distribution, because you can see 15 such rolls. So that means there is a fixed number of trials, and the probability that exactly 10 of these rolls have fewer than 13 faults. That is what our aim, right? So first of all, you have to calculate what is the probability of less than 13 faults. in each row. That is our p value. So first of all, we will define this, the value of, the new value of this thing, probability. So initially, this 1.5 mean rate is for 15 meters. Now here you can see for each roll 100 meters, right? So 100 meters means we should expand this. How will you expand it? 1.5 for 1.5 for 15 meters, and the new value lambda for 100 meters. Correct. Therefore, you just proportionate it. Lambda by 1.5 is 100 divided by 15. So lambda is equal to 100 into 1.5 by 15. So the new value of lambda is 10. So here we will be defining a new random variable R. What is the speciality of the R? Number of folds in 100 meter cloth. 100 meter cloth. Okay. So how this R is distributed? It is Poisson distributed with the value of lambda, that is 10. Correct? The value of lambda is 10. Now you can calculate what is the probability of R less than, because see, find the probability that exactly 10 of these rolls have fewer than 13 folds. So what is the probability of R less than 13? Probability of R less than 13. So probability of R less than 13 means it is what? Probability of R less than or equal to 12. Then you refer the cumulative Poisson distribution table. Okay. So for lambda 10, okay, for lambda 10, the probability of R less than or equal to 12, that if you're referring that table, you will get 0.7916. You can even refer yourself and cross check it. Okay, 0.7916 is the value of what? Is the value of probability of R less than or equal to 12. So we'll write that value here, 0.7916. See, this is not our answer. This is our probability of, this is our p value. That means, what is the probability of getting 13 less than 13 folds in each row? That is 0.7916. Now, such how many rolls we are selecting? Such 15 rolls we are selecting, correct? So out of 15 rolls, find the probability that exactly 10 of these rolls have each fewer than 13 folds. So we will first, now we will define a random variable x. X is what? The number of rolls in which 13 or, sorry, number of rolls in which less than 13 folds. Less than 13 folds. So how will you define this binomial distribution? X is binomially distributed. We have altogether how many rolls? 15 rolls, right? So 15 rolls, and what is the probability of getting in each roll less than 13 volts? That is 0.7916. 0.7916. And now they're asking what? See this question. The B question, we are addressing B question, right? So we are addressing B question. So for B question, find the probability that exactly 10 of these rolls. So probability of X is equal to 10. Probability of X is equal to 10. So what is the formula? Total number of rolls, that is 15. So 15 combination 10. probability of success, that is 0.7916 to the power of 10 into probability of not success, that is 1 minus 0.7916 to the power of 15 minus 10. Clear? And if you are inputting these values, that is your part, you can do it. And if you are substituting all these values, you will get what? 0.11405. So that is the answer. 0. I'll write the answer here. 0.11405. Clear? So that is all about this part. Okay. Now, Bhavana decides to sell her cloth in pieces. Bhavana decides to sell her cloth in pieces. Each piece of her cloth is 4 meters long. The cost to make each piece is 5 pounds. She sells each piece of her cloth that contains no folds for 7.4 pounds. And she sells each piece of her cloth that contains folds for 2 pounds. Find the expected profit that Bhavana will make on each piece of her cloth that she sells. See, you have to, work, or you have to provoke your thoughts, to solve this question. Why? Because you can see it is indirect, it's kind of indirect question. See, what she's going to do, she's going to sell the clothes. Okay. And each piece of her cloth is 4 meters long. You can, from the basic information from this question, we know that for 15 meters, 1.5 volts on average. So in 4 meters, we should first of all proportionate the rate of folds or average folds in 4 meters long. Then what we should do, anyway, it's a Poisson distribution, correct? The manufacturing cost for each piece is 5 pounds, correct? Manufacturing cost is 5 pounds. So she sells each piece of her cloth that contains no folds for 7.4 pounds. And she sells each piece of her cloth that contains folds for 2 pounds. Find the expected profit that Bhavana will make on each piece of her cloth that she sells, correct? So, first of all, what we will do is we will consider the manufacturing cost of each piece, that is 5 pounds. And out of 5 pounds, that anyway, that is actually, the manufacturer, she should meet the manufacturing cost, correct? So manufacturing cost is 5. Though it's 5 is the manufacturing cost, if it is having no faults, that she sells for 7.4. So obviously what happens is, obviously the profit she will be gaining is 2.4, because 7.4 minus 5 is 2.4. But if it is having, unfortunately, a fault, then she has to suffer a loss of 3 pounds. Why? Out of 5, she is only getting 2, correct? So that is the idea. So what we should do is, we will calculate the probability of getting 0 faults and probability of at least 1 fault. So we'll categorize this piece of cloth into, to do this question, this piece of cloth. So this piece of cloth, we have 2 categories, either no faults or at least 1 fault. So if it is 1 fault, 2 fault, 3 fault, all categories can comes under fault, correct? She has to bear the loss. Yes. So first of all, we will define a random variable. What is my random variable? The new random variable is, say, M. What is M? Number of folds in 4-meter length cloth. How this M is distributed? M is Poisson distributed. We know 1.5 fold for 15 meter. And there will be lambda fold for, on an average, lambda fold for 4 meters, correct? So we will proportionate it. Lambda by 1.5 is 4 by 15. So lambda is equal to 4 into 1.5 by 15. So we will get what? We will get 0.4. We will get 0.4, correct? So M is Poisson distributed with a 0.4. Then first of all, you calculate what is the probability of fault is equal to 0. So what is the formula? There is no, I mean, if you can calculate this using a formula, or you can directly input this value in calculator, that's up to you. You will not get this value from the table. That's what that's what I try to convey you. So e to the power of minus 0.4 into 0.4 to the power of 0 by 0 factorial. That is a formula. So if you're inputting this, we will get 0.6703. This is the probability of not having any faults. Then probability of at least one fault. That is what? 1 minus probability of M is equal to 0, correct? So that is 1 minus 0.6703. So 1 minus 0.673 means 0.32967. So we have these two probabilities with us, correct? The probability of no fault. So what is the probability of no fault? That is 0.6703. And the probability of at least one fault is 0.32967. Am I right, my dear students? Now, the idea is very simple. So, either we will get profit or loss. It depends upon the faults. If it is no faults, that leads to profits. And if it having at least one fault, that will leads to what? Loss. So she has to suffer the loss. So what is the profit she actually obtaining? Profit is manufacturing cost we should deduct from 7.4. So that is 2.4 pounds. Then what is the loss? Loss is 2 minus 5. So that is minus 3. Therefore, total profit, the expected total profit is probability of M is equal to 0, that means 0 faults, multiplied by that profit plus probability of M greater than 0 or M greater than or equal. That is what we mentioned, right? So M greater than or equal to 1 multiplied by minus 3. So that is 0.607, 0.6703 multiplied by 2.4 plus 0.32967 into minus 3 pounds. So if you're adding this together, we will get 0.6197 pounds. So the expected profit is 0.6197 per 4 meter cloth. So the answer is 0.6197 pounds. Hope you got it. So that is the idea about this part.